are looking at circuit theorems today. Circuit theorems. And we are starting with the theorem 1. Actually, we don't have theorem 1, theorem 2, theorem 3. Okay. But let's take it that the one that we are tackling is the theorem 1. Now the theorem 1 says, or the property 1 says that the angle a chord subtends at the ends of a diameter of a circle to the circumference is at right angle. That is what? 90 degrees. So we have the theorem diagram here. This is the end of the diameter. You can see this is the end of the diameter AB. And AB is a chord, and it is the greatest chord among all the chords. So when a chord subtends from this end, which is A here, to the circumference, and then from B to the other circumference, the angle that they meet is at right angle, and that's what? 90 degrees. But remember, it subtends at the ends of a diameter to any of the circumference, whether top or down. Still the property holds, or the theorem holds. So you can see that we have the down here, the angle, the line with blue here, the angle created here is 90 degrees, and then the line indicated with green also shows that the angle here is at 90 degrees because they are all subtending from the end of the chord AB. Okay, let's look at the proof. So this is the diagram. Let's try to see if we can prove it. With the proof, you can use the intuitive approach by using the compass and then your rule to prove it. You can also use the geometrical approach, and that is what we are going to look at now. So we can decide to draw a line from the center to C. So let's call this the center. Now we know that a line from the center to any part of the circumference is called what? The radius. So it means that from this center here to C is what? The radius. And from this center here to A is also the radius. And we can say that the length of OA is the same as the length of what? OC. And we can also say that the length of OB is the same as the length of what? OC. Now if that is the case, then we are having what we call an isosceles triangle. And we know that with isosceles triangle, under the properties, two of the lines are equal and two of the base angles too are also what? Equal. If that is the case, then this line being equal to this line, then the base angle here is also equal to the base angle here. Now let's call this angle X. Let's call this angle X, and then this angle to angle X, because the base angle two are equal. So if coming to this very portion too, we can see that the length of OB is also equal to the length of what? OC. Therefore, their base angles too are also what? Equal. So let's call this angle Y. This will surely also be what? Y. Now, we can see that triangle AOC and triangle BOC, they are all isosceles triangle. Now let's try to find the sum of interior angle of AOC and then what? BOC. Now we know that the interior angle of every triangle is what? 180 degrees. So if this angle is X and this angle is X, what will be the angle for angle AOB? Now you can see that X plus plus, let's say, AOB is equal to 180. Therefore, angle AOB will be equal to 180 minus 2x. So we have this angle 180 minus what? 2x. And this angle is also going to be 180 minus what? 2y. Now we can use angle on a straight line. We can use angle on a straight line to find the value of x and y. So angle on a straight line, we are going to sum this angle and then this angle together. So we are getting 180 minus 2x plus 180 minus 2y is equal to what? 180. That's the interior angle of every triangle or sum of interior angle on a straight line. Okay, so 180 plus 180 will give us 360 minus 2x minus 2y is equal to 180. Now we can transpose the 360 to the other side of the equation. We'll be left with minus 2x minus 2y is equal to what? 180 minus 360. So we are getting minus 2x minus 2y is equal to minus what? 180. We are looking for the value of what? X and y. So let's factorize the 2 out. We are left with what? X plus y is equal to what? Minus 180. Dividing both sides by negative 2, we are getting 90 degrees. So it means that x plus y is equal to 90 degrees. Where is x? Where is y? Now this is angle x and this is angle y, which means that when we sum these two angles together, we should get what? 90 degrees. And this proves or ascertains the theorem 1, which says that the angle a chord subtends at the end of a diameter of a circle to the circumference is at what? Right angles. And we have what? Prove it. Now let's take examples and then we try our hands on it with regards to the theorem 1 alone. So let's look at the examples. We have to find the angles marked with letters in the diagram below. So we have two diagrams. So let's look at A. So looking at the diagram, we can see that we have a center O and then a diameter AB. Now we have 30 degrees and then x angle and then this very angle. So when we come back and then look at the theorem 1, we can see that we have a chord AB and that is the diameter. And any angle that is subtended by the ends of a diameter is equal to 90 degrees. So it means that this angle is 90 degrees. And we know that the sum of interior angle of every triangle is what? 180 degrees. Therefore 30 degrees plus 90 plus x should give us what? 180, and you are good to go. So we are getting 30 degrees, which is this one, plus 90 degrees plus x is equal to what? Sum of interior angle of a triangle. 30 plus 90 is what? 180 plus x is equal to 180. So we are getting x is equal to 180 minus 120, and therefore our x is equal to what? 60 degrees. Very, very simple. It's very simple. Now let's look at the example 2. Now the example 2, we can also get a diameter AB and we have the center O. So this should tell you that the angle a chord subtends at the end of this diameter is equal to what? 90 degrees. So this angle is also equal to what? 90 degrees. And we know that if this side is, let's say, Q, triangle ABQ, you know that ABQ is a triangle. Is what? A triangle. Therefore, the sum of interior angle is equal to what? 180 degrees. So we are going to get 50 plus 90 degrees plus 2x is equal to what? 180 degrees. 50 plus 90, we are getting 140 plus 2x is equal to 180. So we are getting 2x is equal to 180 minus what? 140. And our 2x is equal to 40. We are looking for x, not 2x. Divide both sides by 2, both sides by 2. Therefore, our x is equal to what? 20 degrees. Very, very simple. I'll give you one example for you to try your hands on it. So try your hands on this example. Now the suggested answer for this is y is equal to 45. Try your hands in the process to see if you get 45 degrees. Thanks for watching.